dear children, welcome back to chemistry class. We have studied in our previous class how to write the chemical formula of various compounds. As a continuation to what we have already studied, today let us see how to write the chemical formula of few other important compounds. We have already seen how to write the chemical formula of metallic oxide and metallic chloride. So now let us see how to write the chemical formula of a metallic nitrate. This is nothing but a combination of a metallic element with that of nitrate radical. As you see here, the example of a metallic nitrate is magnesium nitrate. Magnesium, which is a metal, combined with the nitrate radical. Now, as per the first step, we are now going to write the symbol of the element along with its valency. The symbol of magnesium is Mg and the symbol of this radical nitrate is NO3. Now we need to write it along with its valency. We have already studied the valency of magnesium is 2 and the valency of nitrate radical is 1. Magnesium, which is a metal, has got a positive valency. Nitrate radical has got a negative valency. Now the second step says that interchange the valencies of the element. Now the valency of magnesium, which is equal to 2, will now go for nitrate radical, and the valency of nitrate radical, which is equal to 1, will now go for magnesium. So after interchanging, we have to write the interchanged number as per the third step. So we write it as Mg1 and NO3 twice. NO3, which is a single unit, that is a radical, we put it inside the bracket and we write 2 as a subscript to the NO3 radical. Therefore, it comes as Mg1NO3 twice. Now, we have already seen that we need to ignore this one whenever there is a 1, isn't it? Yes. So, after ignoring this one, we derive at the final formula MgNO3 twice. So, this is the formula of metallic nitrate. Now, we are going to see how to derive the chemical formula of a metallic sulfide. Metallic sulfide is a combination of a metal along with that of the element sulfur. An example of a metallic sulfide is zinc sulfide, where zinc, which is a metal, combines with the element sulfur. It forms a metallic sulfide, which is otherwise here an example taken as zinc sulfide. Now let us derive the chemical formula of this metallic sulfide, that is zinc sulfide. Now what does the first step says? It says that we need to write the symbol of the element or radical along with its valency. Now we know that in this compound zinc sulfide, the elements that are present are zinc and sulfur. And we also know the symbol of these elements and the valency of elements. So let us write that. The symbol of zinc element is Zn and the symbol of sulfur is S. Now we need to write it along with its valency. We have studied the valency of zinc is equal to 2, and since zinc is a metal, all metals have positive valency and therefore we write it as Zn2+. Now in the case of sulfur, which is a non-metal, and all the non-metals will have a negative valency, and we have also studied the valency of sulfur is equal to 2 and therefore we write it as S2-. Now what is the second step? It says interchange the valencies of the element or radical, which means the valency of zinc, which is equal to 2, will now go for sulfur, and the valency of sulfur, which is also equal to 2, will now come for zinc, which means we are now interchanging the valencies. Now what is the third step? We need to write the interchanged number and finally derive at the formula. So how do we write the interchanged number? Since it is 2 in both the cases, 2 will come as a subscript for each of these elements. So we can write it as Zn2S2. Now we have written the interchanged number. Now since 2 is there for each of these elements, both of these 2, that is the same number, will get cancelled, and therefore we derive at the final formula as Zns. So the chemical formula of zinc sulfide is Zns, because now here we are ignoring this 2 since 2 is present for each of these elements. And that is why we ignore this 2 and write it as Z and S. Now let us see the chemical formula of metallic sulfate. How do we derive that? Just like all the other cases we have seen, metallic sulfate is a combination of a metal along with that of sulfate radical. Just like how we have derived for other compounds, we can derive for this also. First, we need to write the symbol of the element. And we know that the elements that are present in the compound potassium sulfate, which is a metallic sulfate, the elements are potassium and sulfate radical. So the symbol of the element potassium is K, and we have studied that the symbol of the radical, that is sulfate radical, is SO4. In our previous slide, we have seen that the valency of the metal, that is potassium, is equal to 1. Since potassium is a metal, it has got a positive valency. Therefore, we write it as K1 plus. Now, sulfate radical, that is with the symbol SO4, it has got a valency of 2 and also a negative valency. Therefore, we write it as SO4 2 minus. 2 minus will come as a superscript. Now, what is the next step? We are going to interchange the valencies of the element or the radical, which means the valency of potassium, that is equal to 1, will now come for the sulfate radical, and the valency of sulfate radical, which is equal to 2, will now come for potassium. Now we are writing the interchanged number, that is K2, as you see here, SO4 1. So we know that when there is a 1, we are going to ignore that 1, and therefore we are going to derive at the final formula, that is K2SO4. Now since there is no subscript that is available for this SO4 radical, we are not putting that inside a bracket as we have seen in the previous case. So the formula is K2SO4. Now let us see how to derive the chemical formula of metallic hydroxide. An example of a metallic hydroxide is aluminium hydroxide, which is nothing but a combination of a metal, that is aluminium, along with the hydroxide radical. Now we know that the elements that are present in this compound aluminium hydroxide are the element aluminium and hydroxide radical. So as per the first step, we need to write the symbol of the element or radical along with its valency. So we know the element aluminium, its symbol is Al, and for the radical hydroxide, the symbol is OH. And we have already studied that the valency of aluminium is equal to 3, and since it is a metal, it has got a positive valency, since all metals will have a positive valency, and therefore as per the first step, we write it as Al3+. Now in case of hydroxide radical, it has got a valency of 1 and it is a negative valency, therefore we write it as OH1-. Now as per the second step, we need to interchange the valencies of the element or radical, which means the valency of aluminium, which is equal to 3, will now go for the hydroxide radical. So we need to write the 3 under OH, as you see here. And now we are going to interchange the valency of this one, which means the hydroxide radical, which has got a valency of 1, will now be interchanged for aluminium. So now we can write 1 under aluminium, because this valency 1 of hydroxide radical will now come for aluminium. So how do we write the interchanged number as per the third step? Al1, as you see here, and OH thrice. Now I have already told you, since hydroxide is a radical, we need to place that inside a bracket whenever there is a subscript to that radical, and therefore we write it as Al1 OH thrice.